we're going to talk about using properties of proportions at first to solve for x. And to solve a proportion, if you guys remember or not, cross multiply. So I'm going to do 2 times x minus 2 is equal to 9 times 4. So for number 1, x is 20. Does this look at, oh, hold on. We're going to do number 3 next, because here we have x's in both proportions. So I have 2 times x plus 1 is equal to 4 times x minus 5. So I get 2x plus 2 is equal to 4x minus 20. And subtract 4x from both sides, or you could subtract 2x from both sides, that's up to you. I'm going to subtract 2 from both sides, and I get negative 2x is equal to negative 22. So dividing both sides by negative 2, you get x is 11. Okay.
So let's make them.
Now, okay, so if you have the same shape but not the same size or position, you're not congruent, you are similar. Okay, so similar triangles would be like I have this triangle and this triangle. Same basic shape. This one's little, this one's big. And the symbol for similar is like congruent but without the equal. So it's just the squiggle. Okay. So they're similar if their angles are congruent and the ratio of the lengths of the corresponding sides are equal. Okay. Let's say I had this is A, B, C, and this is D, E, F. Okay. So angle A would have to be congruent to angle D. Angle B would be congruent to angle E, and angle F is congruent to angle C. I did that backwards, but you get the idea. And then the length of their sides. So if this is side 1, 2, and 3, and this is side 4, 5, and 6, 1 over 4 would be equal to 2 over 5, which would be equal to 3 over 6. And this is the sides, not actual, like 1/4 is not actually equal to 2/5. But the length of side 1 would be equal to, over the length of side 4. Does that make sense? Okay. If we're referring to them, we have to say that triangle, if I say ABC is similar to triangle, I have to put them in the same order, DEF. So if I say ABC, I can't say FDE. Okay, it would have to be DEF, and that's because the congruent angles have to be listed in the same order. Side length ratios. Okay, so if polygon ABCD is similar to EFGH, then the following things are true. Okay, so angle A is congruent to angle E. Angle B is congruent to angle F. Angle C is congruent to angle G. And angle D is congruent to angle H. Also, if you look here, the length of AB is 6 and the length of EF is 3. So this is what I meant with the side length ratios. If I do EF over AB, that's 3 over 6, so that's 1/2. Well then, if I do FG over BC, that would also have to equal 1/2. And HG over DC would also have to equal 1/2. And EH over AD would also have to equal 1/2. So I don't know what these lengths are from this picture because they're not labeled, but whatever numbers are here, if I had this number here, so if, for example, if this was a 4, this would be an 8. Because 4 over 8 equals 1/2. Does that make sense? Okay, so let's just do another kind of hypothetical. If this was 2 here, what? No, can we see that 2? We can't see that 2. If this was 2, what would this length here be? 4. And if this was 3, this would be 6. So that's what they mean by the ratios of the lengths have to be the same. Does that make more sense? Okay. Okay, so here we have 2 similar polygons. We want to find the values of x, y, and z. Okay, so what we first need to do is we need to look at these and we need to figure out which sides are, or not which sides, but which angles are congruent and which sides are corresponding. So I'm going to, obviously this flat side here corresponds to this flat side there, right? Okay, and then that means this short part here corresponds to this short part here. Now these aren't congruent, they're just corresponding. This corresponds to this. this one corresponds to this one. And finally, this side corresponds to this side. Okay. Now the angles, angle Y is between yellow and red. Did you see that? So angle Y is going to be congruent to this angle over here that's between yellow and red. So angle Y is 90 degrees. Did you see that? So that's going to be this one right here. How about Z? Z is between pink and blue. So we look for the other angle between pink and blue. So Z is 145 degrees. Okay. As for the side lengths, okay, yellow corresponds to yellow, not congruent, corresponds. So I'm going to say x over 15. Red corresponds to red. Now these have numbers. And I put x on top, so I also have to put 6 on top because the numerator has to come from the same figure and the denominators have to come from the same figure, right? So if I did small figure on top, large figure on bottom, I have to keep doing small on top, large on bottom, or vice versa. So if I did x on top here, I do 6 on top here. 15 corresponds to 10. Or I'm sorry, so red corresponds to red, so 6 over 10, and then yellow to yellow, so x over 15. Once I figure that out, to solve it, I'm going to cross multiply, and I get 10x is equal to 90. So x is equal to 9. So this side here is 9. Let's just do another one. Let's say hypothetically we knew that this side here was 5. And we want to find, that looks like an S. Okay, let's say we want to find this side here and we're just going to call it Q. So I would say that 5 over Q is equal to 6 over 10 because I still have 6 and 10, right? So 6Q would equal to 50. Then divide by 6. Well, shoot. Okay, so it's going to continue. So 8.3. All right, so we have two similar polygons. We're going to find the values of x, y, and z. Okay, y matches, or here, we've got this side goes with this side. This side goes with this side. This one corresponds to this one. And this one corresponds to this one. So y is between blue and yellow. So this other angle here is between blue and yellow. So y is 75 degrees. Does that make sense? Okay. And then z is between green and blue, and this angle here is between green and blue, so z is 87 degrees. And then I have x, which corresponds to 9. And then I have 4, which corresponds to 12. So I do small over large, cross multiply, and I get 12x is equal to 36. So x is equal to 3. Okay. This one's a little different because if you look, do you see our right angle? So this one, this second figure is like that. Take that first figure and it's like flipped over. Do you see that? So you just like flop it like a pancake.
Oh, just flip it over.
Yeah. So it's like
Just see how they're not turning it.
yeah. No, it's not turned. It's flipped. So this 6 corresponds to this 12. And then this 4 corresponds to the x. And then this side to this side. And then this side to this side. And then that side to that side. Okay. So what we have is y is between red and green. So we look for the red and green angle. So that's 112. Okay. And now I have here, I've been having 2 angles and only needing to find one side. Here I have one angle, but I need to find 2 different sides, x and z. So I'm going to look, x corresponds to 4. Here I have 6 and 12, so I'm going to do 6 over 12. What does 6 over 12 equal? 1/2, right? So I could set this, rather than multiplying by 6 and 12, I could reduce it if I wanted to. Whoops, not x over 4, 4 over x. And make that 4 over x is equal to 1/2, couldn't I? Since this one reduces, which would give me x is equal to 8. And then I can still use the same 1/2 when I try to find z. And I can say z over 10 is equal to 6 over 12, which is 1/2. So 2z is equal to 10. So z is equal to 5. Did that make sense? Now you don't have to reduce it. If I multiplied this out, I would have gotten 6x is equal to 48, and I still would have gotten 8. So, you know, reduce it if you want to or not. Yeah, if it's one of the proportions. Because what happens is the angles are equal, they're congruent. The sides are in proportion to each other. So to find the angles, they're the same, they're just congruent. To find the sides, you have to make a proportion. Do you guys need to see these, or you feel like it's okay? Which one? Okay, so I have one, it's okay. Does anybody else need to see any more? All right. Why don't you go ahead and try these two and see how you do.